Howdy, and welcome to our presentation on superconductivity with Demetra Baker, Ryan Beats, Kelsey Golden, Amber Grunewald, and Bridget Wong.
What is superconductivity? As we all know, a lot of energy is lost in wires that carry electric current due to resistance. Superconductivity is a revolutionary way to have the transfer of electricity with zero resistance. How we produce superconductivity is through superconductors. A pro of superconductors is that we can save huge amounts of energy and that they can allow us to cram circuits into confined space. But a con of superconductors is to achieve zero resistance, superconductors need to be cooled at 4 degrees above absolute zero.
Superconductivity is so useful due to its ability to allow for electrical energy to be transferred from point A to point B with zero resistance or 100% efficiency. This means that no electricity is wasted and the current will run on forever if the temperature is below the critical point. They're able to do this because the electrons become free, losing their identity, and are able to easily slip past each other. Regular superconductors lose energy due to their resistance, will lose electrical current when the source is removed, and need multiple conductors with huge gauges to transfer power from one place to another. In comparison, superconductors lose no energy, can continue running a current even when the source is removed, and are able to use just one single superconductor to transport power from one place to another with no insulation burnout.
A few of the limitations of the uses of superconductor tech are related to the price. So the extremely low temperatures that are needed to ensure no resistance are very difficult to achieve, requiring a lot of energy and therefore very expensive. As well, the materials that are used to create the superconductors are frequently very brittle, which makes them hard to shape without damage, especially at cold temperatures. You also can't use the superconductors with AC electricity, alternating current, as alternating current destroys Cooper pairs. And one of the problems with this is that you can only use direct current, which cannot be easily transformed. In addition, only a certain amount of current can be transmitted through superconductors before they lose their superconductivity and essentially lose their functionality.
So the big question is if we have actually achieved superconductivity. The short answer is yes. However, it comes with a big caveat. Until recently, it has only been produced in very low temperatures, like near 0 Kelvin, or about negative 450 degrees Fahrenheit. Every few years, though, a new breakthrough occurs, and scientists produce a superconductor that functions at a much higher temperature than before. In fact, in May of 2019, just last year, scientists in Germany were able to produce a superconductor that operates at 250 Kelvin, or about negative 10 degrees Fahrenheit. They did this by conducting electricity through a lanthanum hydride at a pressure of 170 gigapascals. That's the same amount of pressure as about 1.6 million atmospheres, or about half the pressure that the center of the Earth is under. This represents a trend among recent superconductor research, which utilizes ridiculously high pressures to keep the molecules of materials together while conducting electricity.
So I'll be talking about the future applications of superconductivity. There's actually a bunch of future applications for it. I've listed some here, as there are many more uses for future uses for superconductivity. As you can see on the slides, long distance, low voltage electric grids with no transmission loss is one of them. Fast magnetically levitated trains, ultra high speed supercomputers, super efficient motors and generators, and power transmissions are some of the future uses. One of the more exciting applications are maglev trains, or magnetic levitation trains. These use superconductivity to levitate trains above the rails, which can help achieve fast speed travel as it eliminates friction. This could be our future of transportation. There's a prototype already built in China, but maybe in the future a lot more countries will have it. Some of these future applications are in the demonstration stage, and some of them are in the experimental stage. Some of the designs may be around sooner rather than later, and hopefully we will be able to see some of these in our everyday life in the coming years. That's our presentation. Thanks for watching.